So, good morning. First, I'd like to thank the organizers for inviting me. It's nice to be here to give a talk, and it's also nice to hear what everyone else is working on at the faculty. Today, I want to talk about two projects that we had recently, so an ODIS project and a European project. The work that we do in our lab is not really focused on climate change, but since it's such a pervasive process, it kind of touches on everything that we do. And so these two projects involve kind of forest dynamics, climate change, disturbance, and I worked on them with two of my colleagues, Matteo Cerioni, who's a PhD student who's just finishing his PhD now, and Nagel. So, I just have one background slide. I'm sure most of you have seen a figure like this before. So this is a very recent figure of Earth's climate budget. And so these curves above the x-axis are climate or carbon emissions, right? So you can see fossil fuels here and land use change, which has remained relatively stable. And then below the horizontal line are the carbon sinks, right? So here you see oceans, land, and so land is mostly forests, right? So the oceans and the forests have been absorbing quite a bit of carbon since the 1950s, and then everything else that's not absorbed remains in the atmosphere, and that's what's causing global warming. And I don't know if you can see it, but this green line here seems to be leveling out a little bit, right? So there's a lot of concern that forests are not absorbing as much carbon recently than they have been in the past, right? They're not continuing that rate of functioning as a sink. And that's very bad news, because if there's the forests are not acting as a sink, that means there's more carbon going into the atmosphere, and it results in accelerated global warming. And so there's a lot of research right now that's trying to figure out what's happening with this. So some people think it's related to maybe declining photosynthesis, but many studies suggest that it's related to either increasing rates of background tree mortality. So when I say background mortality, I'm just talking about the natural rate that trees die, usually about a rate of 1% per year. So one tree out of 100 every year dies from background mortality. Or it could be related to increasing disturbance, so things like fires and insect outbreaks that kill a lot of trees at once. So that's something that we're trying to figure out. And there are a lot of studies, especially in North America, that do show that rates of background mortality are increasing. But in North America, especially in the western part of North America, it's gotten quite dry and hot, disproportionate to other parts of the world. What's happening in Europe is less clear. So this is a figure from a fairly recent study looking at canopy tree mortality over the past few decades. And this particular study was based on remote sensing of forests, so from satellites. And these authors do indeed find that mortality is increasing, but you have to keep in mind that most European forests are managed. So something like 80 or 90% of the forests are managed. And so this increasing tree mortality, in this study, they attribute mostly to increasing rates of tree harvesting, right? So we can't really figure out from managed forests what's happening with tree mortality. So the only place we can really understand this is to look at unmanaged forest or old growth forest. And we're quite lucky in Slovenia. We have quite a few of these small old growth forest remnants. And we're also lucky that since about the 1980s, we've been monitoring tree mortality in permanent plots in these forests. So each of these forest reserves has large plots where we have tagged trees, and we return to these plots about every 5 years, and then we can calculate rates of demography, like mortality and recruitment. So these are what these forests look like, right? They're typical old growth forests. They're mostly dominated by beech, big trees, old trees, a lot of dead wood. And these two figures show you what's happening with mortality in our forests in Slovenia. So on the y-axis, we have annual mortality. This is just for beech trees, and so those are the main trees in our forest, for smaller trees and larger trees, and each of these lines is the mortality rate for a different forest reserve. And what you can see is there's variability, but mostly the background mortality hovers around 1%. There are some peaks here, and those are related to disturbances, things like ice storms and windstorms. But when we remove those disturbances and we do analyses on these time series, we don't find any evidence that mortality has increased since the 1980s in our forests. So that's quite good news. But this data set's also quite small. It only has about 30,000 census observations. And because forests are long-lived and mortality is quite rare, you need much larger data sets to see what's happening with mortality in relation to climate change. So what we did in one of these projects is we combined similar data to what we have in Slovenia. So we looked for permanent plot data from unmanaged forests all over Europe. And so we have a new data set now that has about 1.5 million trees and many million census observations. I know this is hard to see, but going back to the 1940s. And I can't show you the results of this because there's a PhD working on this right now that's hosted in Switzerland. But I can tell you that when we look at long-term rates of background mortality from this data set, for most tree species, like European beech, we don't find any increase in mortality over the past 50 years. So it's different than what we're finding in other parts of the world. So that's, again, good news, right? Climate change is not resulting in increased rates of background mortality. What about disturbance, though? Right? I mentioned in the beginning that disturbance could be an important factor. You've all seen things like this, right? Disturbances that kill a lot of trees at once are pretty common in our forests in Europe, especially in Slovenia. We have very disturbed forests. And some of these disturbances are getting kind of large. This is a picture from this, from the Kutuma Valley. There was a large windstorm that damaged trees there last year, and this particular storm damaged forests throughout Slovenia and into Croatia. You all remember this very large ice storm in 2014, which was followed by a very large bark beetle outbreak. Those are some of the most damaging disturbances in Slovene history. And these kind of big disturbances are happening everywhere. So in Central Europe, there's been very large bark beetle outbreaks the past few years. There was a very large windstorm, for example, in northern Italy a few years ago. And so there's increasing concern that disturbances are getting larger and more severe, right? And that would also result in more carbon going into the atmosphere, especially if these areas are not able to reabsorb carbon very quickly. And so one thing we're curious about is that really happening? Are disturbances getting larger or more severe? And so another thing we did inside the European project is we gathered as much data on disturbance events across the continent over as long of a time series as possible. And so this figure shows the main result of that study. And you can see, so the y-axis here is damage in cubic meters per year across several different common disturbance agents like wind, fire, bark beetles. And you can see that there has been an increase, okay? Especially for some disturbance agents like bark beetles. So we know that there's more damage from disturbance. It's hard to say how much of that we can attribute to climate change. The other thing that we've been really concerned with is what happens to the forests after these big disturbances. So if you look in the literature right now, there's a lot of studies, again, in North America, where there's very big disturbances, like very large fires, that suggests that after these large disturbances, the forests are not recovering. You can imagine if there is a fire that burns thousands of hectares, right, it's difficult for seeds to come in, there's no more seed sources, and if seeds do come in, the seedlings are very vulnerable to drought and heat stress under climate change. And so there's a lot of evidence suggesting that there's kind of a decline in forest resilience in forests around the world. But we don't know what's happening here in Europe. So this was another kind of effort that we tried to resolve in this research. And this was one of the main topics of Mateo's PhD. So he basically asked, are European forests resilient to large and severe disturbances? And so what Mateo did is what he gathered regeneration data taken from plots set inside areas that were disturbed by large and severe disturbances across the entire temperate zone of Europe. And he collected some of the data he collected himself, and some of the data were contributed by other studies throughout Europe. And what he ended up with was a data set of about 100 sites spanning about to 50 years before the last inventory. Okay, so a pretty big time window of forest recovery. And it included data on wind, fire, and bark beetle outbreaks, so the three main disturbance agents in Europe. You can see there's a pretty big spatial coverage here, much more wind than fire, for example, but still quite a good data set. And he ran a number of, I would say, kind of complex statistical models to look at what's driving tree regeneration after these big disturbances. I'm not going to go into that. If you want to read, if you're interested in that, you could see the paper that just came out. But I just want to show you some of the raw data from his study. So these box plots show the distribution of tree regeneration densities in these three different disturbance categories. So bark beetle, fire, and wind. And you can see that the densities, I don't know if you know much about what you should expect for tree regeneration density. So we have between like 5 and 10,000 seedlings or saplings per hectare in these sites, which is not that high of a density, but still it's not too bad, and they're doing quite a bit better than fire. Fire, the density is quite low. And then what we did was we compared those densities to the density of trees that were on these sites before the disturbances as kind of a target, right, that what we want to see the forest get back to. And you can see that for both beetle and wind, the tree regeneration densities met those targets, right? So we could say that those forests were recovering quite well. Whereas for the fire sites, they were not recovering well at all right? There's a lot more variation here. Matteo also looked at whether or not these sites are recovering compositionally, so whether or not the tree species were the same as the tree species from before the disturbance. And again, there's a lot of variability here, but again, for fire, these sites are not recovering compositionally. Okay, so I think that the take-home message for this is quite bad for us, because if you can imagine, you saw from some of the previous speaker too, that the Mediterranean climate or zone is definitely expanding into Central Europe as climate change progresses. And as that continues, it's likely that we will probably see more fire in our forests. You all remember, right, this fire that happened in 2022 in the karst. That was a fairly large fire. And you can imagine when all of the overstory is killed, there's no seeds left, and also the soils are quite shallow here and prone to drought, that a forest would have a very difficult time recovering here. Here's another event. I don't know how many, it's hard to see this slide. This is a fire that burned in the same year near Predvor, so in the foothills of the Alps. This is, I think, a much more interesting fire because it burned in a fir beech forest. And those forests are typically very wet and they don't carry fire very well. And so when they do burn, because these trees have very thin bark and they're not adapted to fire, unlike pine forests, all the trees tend to die. And so we ended up with after this area was salvage logged, right? There's nothing left, it's just bare mineral soil and some herbs. And you can imagine that a forest will have a very difficult time recovering on a site like that. Okay, so here's the take-home message from all of this put together. Rates of background tree mortality are not increasing in unmanaged forests in Europe, all right? So that's good news, right? Because if climate change is causing an increase in background tree mortality, say going from 1% to 2%, that would mean that all of the trees in our forests their lifespan would be cut in half, right? So that's not good for climate storage, or for carbon storage. Except for wildfire, temperate forests in Europe, we think, have been quite resilient to large and severe disturbances. So over the past 50 years, they've recovered quite well. And I think that that's pretty good news for these new EU policies. So if you follow the new EU biodiversity strategy and forestry strategy, both of those strategies are calling for that we strictly protect 10% of the European landscape. Right now we have about 1% protected strictly, which would mean that we can't really do anything there. There would be no forest management or no agricultural practices. And that's good news because in these 10% of areas that are strictly protected, because old-growth forests and strict forest reserves are quite stable and they're good at absorbing carbon and mortality is not increasing, then they would be a pretty good tool to absorb more carbon. But, like in other parts of the world, for example, North America, it's likely just a matter of time until the climate change progresses enough that we start seeing this increases in background tree mortality, perhaps increases in disturbance severity, and definitely there will be problems with forest recovery because of susceptibility to drought. All right, so right now the situation still looks okay, but it's only a matter of time until things start getting worse. So a little bit of good news and a little bit of bad news. Thank you.
Very much, Tom. Now we have 3 questions with Slido, and then maybe if there are some questions, yeah, just raise your hand, please. Okay. So first question: have you found any studies that connected increased bark beetle incidence with lack of forest fires that would also reduce pest populations?
Okay, I'm not sure if I understood the question. Have we found any studies that
connected the increased bark beetle incidence with lack of forest fires that would also reduce pest populations?
Lack of forest fire. So you're saying that because we don't have forest fire, maybe that's whoever asked this question, that there's more fuel in the forest and therefore there's more bark beetle? I'm not sure. Yeah?
I asked a question. So if you have forest fires, probably the pests die also. And then if there's more forest fires, maybe there's less bark beetles there to kill the trees. I don't know. Just
I think that's, yeah, I mean, I think that if we had more forest fire potentially indirectly killing beetles, that would be the least of our concerns because the forest fires would be more of a problem. If you look at what's happening with like modeling studies, like the former speaker was talking about, when people model what happens to bark beetle populations over the next century, you find that over the next, you know, as temperatures warm and bark beetles go higher and higher up in the mountains, which is inevitable, and eventually all the spruce is removed from Europe. Okay, and so then the bark beetle populations crash because there's nothing for them to feed on anymore. So, you know, we have to move away from spruce. That's a very dire scenario. It won't happen everywhere, but it will happen that there will be more bark beetle outbreaks at higher and higher elevations.
Okay. Yes, next question. How do forest regeneration rates after fire depend on forest type regarding species composition?
That's a good question. So, it depends. If the forest is well adapted to fire, so if you were to go to like a Mediterranean forest type, right, then those species, the species can both resist fire, so they survive, or if they die, they've evolved adaptations to resprout or reseed after the fire. So if it's adapted to fire, then it does quite well. If it's a forest like the one that I showed you, like this fir beech forest, then it's very ill adapted to fire, and it won't recover very well. These pine forests in Slovenia, those are not exactly natural forests either because they were all planted there. But those pines have thick bark, and they can also survive fire quite well. Although the fire a few years ago was very severe, and you saw, if you drove through the area, you see areas that are completely dead, some areas that are partially dead. So it depends mostly on fire severity.
Okay, thank you. And quick third question. How can forestry become more resilient to climate change? Can you provide any good practice of concrete example of that?
Okay, that's a good question. That's something that people are trying to figure out. So, in the past, we would have said that the kind of management that we do here in Slovenia, so this uneven age management or close to nature management, is the best we can do, and that's all we need to do because it means that we have a lot of different size trees, different generations of trees in the forest. So even if a disturbance kills the canopy, there's an understory that's able to recover very quickly. But that strategy is probably not sufficient anymore. We need to start introducing new species to the forest, right? So species that will be adapted to a climate that's around in 100 years from now. So we can't just rely on what's the species that are there. We need to actually help move species into our forest. That would mean like helping oak in beech forests or moving fir and spruce to areas where they can survive, things like that.
Okay. Any other question? Otherwise, you will have time at the break. Okay. Thank you very much, Tom.